Here we are. We meet again. This is the final video for this Securian Bootcamp, so I'm pretty pumped about that because there's a lot of stuff that I want to dig deeper into outside of just this Securian Bootcamp, a lot of which has derived from this. There's a lot of ideas and things that I'd like to try. So with that being said, we shall get started with Audit Findings 101 as well as Audit Findings 201. And this specific series of blog posts for this section of the Securian Bootcamp was a slog for sure. It was not as bad as the Solidity section, which was pretty intense. This one was still pretty tough. Reason being is that a lot of the snippets here are in context of a larger audit. But the one of the many benefits that I've noticed from reading through a lot of this stuff was you start to get an idea of what's discussed and you start to pick out some patterns and the flaws that these auditing firms find within the contracts. And that was one of the many insights that I derived from this, and hopefully that you'll do the same when reading through these specific posts that are linked here. So first things first is I want to show you some major takeaways here. And one of a few tips that I want to, that's me practicing my drawing and make sure this works. That's let me point this out to you, internet. These are clouds, these are trees, these are mountains, and then this is the box where my face should be. You're welcome. All right, so some of the major points I wanted to point out here is when reading through this, I realized that there was a technique that I used that I thought was somewhat effective, and that was simply when reading the snippet of code or the snippet of text within the blog post, because there's 101 within each Substack post. When you read that section, my recommendation, at least for me, was to skip over the specific code naming for the function that they're referring to or the contract they're referring to, because sometimes by reading that, it kind of overloads your mind and you start to realize, like, I don't know what they're talking about, this is too confusing. So if you just skip over the naming for the code snippet and just jump right into the words around it to get an intuitive understanding of what they're discussing and what the flaw really is, then you can go back and read it once again referring to the naming. So skip it first and then read it later. That's one bit. And to show you an example, really all of this stuff, so you can read through here, so you can see it's referring to parse FLA execute. That's a function it's referring to. I can kind of intuit what this means, but I'm not looking at the entire code snippet, so it's harder for me to understand. Same thing as they refer to Aave v2, DIDEX, DS proxy, execution action. So some of that stuff is somewhat understandable because it might be broader, but my recommendation for that stuff is instead of getting caught up in the naming for what's being discussed, such as here or here, things like that, just skip over that and just read the text around it. And just, in my mind, I would say, like, in a scenario where a user takes a flash loan from this function, gives a flash loan wrapper contract, blah, 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 blah. So I just say, like, this function for this, and, like, for this, it would be like this, this function, and I'll just say function in my head instead of saying the actual text, and then I'll come back around and read it once more. And for me, that's just more effective. Maybe it's not for you, but I thought I'd, share my learnings. Another bit of information that I wanted to share here is when reading through this, I've already kind of touched on this briefly, is that when you read through it, you start to find patterns. You start to pick up items because if you read the 201 small snippets from different audits, you start to see different things that are mentioned, at least common words. And this actually relates back to a few posts that I've not linked here, but if you just Google best practices, and there's one here that I'll share, best practices, good patterns, things like that, you'll see people referring to security potential issues with contracts, and one of those are access controls. Another one is underflows and overflows for integers, which is less of an issue now because there's checking within Solidity. Visibility around the functions is a common pattern that I've seen. Input validation is another one that's mentioned quite often, where you want to do a lot of checks prior to actually interacting or doing any type of edits or anything like that. So you'll see that there. Another one is reentrancy, is a common one everybody talks about. So there might be 100 items discussed, but in those 100 items there might just be a 6 or 7 or 8 common things discussed in each, just in a different context for that code snippet. So that's one interesting thing I came across, and one thing that I hope to pull out of more of the readings and watching lectures and things like that I come across, because in the beginning it seems so overwhelming because there's 1,000 different types of exploits and vulnerabilities, and you kind of don't really know where to start, or you think to yourself, how am I supposed to actually remember all this? But in the end, it's very similar to most skills that anyone derives, is that there are common patterns, frameworks, mental ways of seeing the world and things to focus on. So you're not necessarily using the entirety of all of your cognitive load in your brain. You're only using small subsets because you know from experience where to look first and what patterns to look for. So that's one thing I wanted to kind of tell myself and tell you, that it's okay, and you'll work through it. All right, so that out of the way, go to the next bit. All right, here I wanted to point out a few common recommendations. So there were common recommendations made throughout this. So every single snippet of code for that audit firm they would usually have some sort of recommendation. And if we go back, you can see a few here. So you can see recommendation here, recommendation, recommendation. So each one of these are recommendations based off of these audits. And if you actually click into any of these, they're audits from different firms. So this one's consists of diligence, and they have a certain format and structure of how they both present and discuss these exploits or vulnerabilities. And if we go through here, I think there's TOB, yeah, it's a Trilobits, which is a really good one. They do it in a PDF format, so it's not as easy to look at for me on my phone when I read this. And they're all in big, massive PDFs like this, where you can read through, and it kind of explains the item and then the recommendation. And that's what I'm referring to here. And the point that I wanted to make here is that there's 3 common recommendations I came across here. And actually, no, this is a general piece of advice, so we'll say 2 recommendations. The first one is talking about the way that transactions are transferred. And that's a pull pattern versus a push pattern. Sometimes when you're sending funds, a contract will push the funds to another contract instead of requesting that the contract actually pull the funds. So if we have, why is it doing that? Internet? This isn't cool, yo. All right, so say we have contract B and contract A, and contract B is a contract that has the funds that needs to get them out, so either pull or push. Sometimes that contract will push that funds to contract A, and sometimes it'll ask A to withdraw the funds instead of pushing it. And here, one of the major reasons why that people prefer push over pull is actually a denial of service attack. And the simplistic way you can kind of explain this is that if you have contract A, here, contract B, and you're doing a push pattern, so it'll be PU for push, and you're pushing the funds to contract A. Well, when you're pushing funds to another contract or an account, there's usually a fallback function. And that fallback function is a way for them to receive and accept payable transactions. Well, if this fallback function is not inside of contract A, then what's going to happen is most likely this contract B is going to stall. And when it stalls, then it's a denial of service attack on everybody else that wants to interact with that transaction because it can't function. It's waiting for that fallback function to actually respond so they can actually execute the entirety of it. And one thought that came to mind for this specific attack was actually TCP/IP. So, TCP, I think. So the TCP transaction, between 2 machines, right? So you have a send here and then a send back and a send here through the 2 different machines. Well, when that's happening, there's usually, I forgot the specifics, but it's like a request, a response, and then a request or something like that. But there's a handshake, a 3-way handshake that occurs here. And that 3-way handshake is basically similar to what this fallback function is doing, where it's basically the ending piece of that handshake so the transaction can officially execute. And with me butchering that explanation, I wanted to show a better explanation here, a video explanation that I'll link below in my video, which is from the smart contract programmer guy. And like I said, you should watch every single one of these videos in this playlist if you're interested. And it really walks you through a lot of the common attacks, and he explains it in a really understandable format, shows you the code, executes it, show the exact flaw and things like that. So this video specifically walks through denial of service, and in the context of that, he talks a lot about the pull versus push pattern. Another post that I'll share is this GitHub repo here. I've not read everything, but it is a good reference to see kind of what patterns are considered best and good. And this might be slightly outdated because I can see that it's referring to 0.4, but there's still a lot of good insights that sort of derived from here. And they walk you through some of the common patterns that one should consider when developing in Solidity. All right, with that out of the way, we will move on to the next piece. The second common recommendation that I've seen and I've discussed with you previously, so if you're curious to kind of get a deeper dive into what this means in the code snippets, go back to, I think it's the previous video from this one, so it's tools and techniques for auditing. And when looking into that, or maybe it's Solidity, remember, it might be Solidity. But in a nutshell, if you just Google this, you'll figure out that this is a common thing that's discussed within development. Reason being is that when a function is created, there should be parts of that function that exist. So if we have our function here, and inside of this function, there should be three things that occur. So first is the check. So this is point 1. Second is the effect, and third is the interact. So check is basically using a series of modifiers or require statements to ensure that whatever is happening has been checked. So you're checking that the balance is set the way it should be. You're checking if the owner is the person who should be interacting with us, things like that. Once you've gone through this piece, the next piece is actually doing the effect. So this is usually the function, the for loop, something that adjusts the variables and adjusts the data within the contract or the areas that the contract interacts with. And last, once this change has occurred and this effect has occurred, then you're actually going to interact. So that's interacting with another function, that's interacting with another contract, that's interacting with some sort of interface elsewhere. That's the last piece. And sometimes when you look at these auditing snippets inside of the Substack post, you'll see that slot 1 tends to be here between 2 and 3, where the check doesn't occur until later, or the effect occurs too late, or things like that. And when you misplace these items and you don't use the pattern correctly, that leads to a lot of reentrancy attacks, where someone can actually do a common attack where they can basically continually keep extracting the funds because the balance has never changed. And there's some videos I'll kind of share with you that explains that better. But in a nutshell, that's a common thing that you'll come across. Lastly, there was a good bit of advice from Trail of Bits where it was very general. So I wanted to kind of pull it out, and it was just one of the posts, and it was probably specific to the context of the code they were auditing for Origin Dollar, but I thought it was general enough to kind of mention here. And here you can see they basically state that anytime you're working with a function that's not non-view, then you should add reentrancy guards. So another way of saying that is if the function is writable by another person or another contract, then you should add a reentrancy guard. So if there's some sort of ability to execute in this function, and it's not just read only, you're not just reading information out, and you're actually doing some sort of execution or function on the data or something that's writable, then there's a really good chance that if you don't have reentrancy in there, there's a possibility for a reentrancy attack or something like that. Another general piece of advice they gave there was something that was quite interesting. So making sure that all transactions that occur allows a revert statement. The reason this is important is that when someone inputs something into a function and the input here is incorrect, either it's the wrong data type, too large, too small, coming from the wrong location, things like that, the transaction is going to revert or should revert. And if the transaction doesn't revert, that means that that wrong input can then maybe siphon off data, siphon off funds, things like that. And that's one kind of general piece of advice. And then the last one here is a common discussion. Similar to a lot of this stuff, you'll see that there's a lot of connections between Web 2 security, AppSec, and Web 3 stuff. And this is a common occurrence within Web 2, which is basically stating that you should always understand the connections that you have with the outside world. What are your dependencies? What libraries are you using? What contracts are you inheriting from? What contracts are you interacting with and calling to and getting called from? And if it's an untrusted contract and you're unaware of it being a part of a subset of contracts you've allowed this contract access to, then you should disallow it. Now this is the same thing with Web 2, where we have tons and tons of dependencies that we rely on when we're developing, and we're pulling in all kinds of libraries and things like that. And that is dependency hell, where you have a series of stacked items, and any of these things get pulled out, then everything collapses. And that's a common occurrence here. Now on to another piece. All right, so this is similar to the check and effect piece. So we've already talked about that. So this point that I'm making here is relevant to this pattern. And the point here being made is actually in one of the audit pieces, it mentions that modifiers should do common checks for different functions. So many of the checks that happen within this pattern here are utilized via modifiers. And I have a code snippet somewhere here that shows this, where let's expand this out so you can see everything and make it smaller so I can see everything. All right. Here we have a contract owner doing a series of items. So we have the contract owner, state variable getting established, constructor, and then we have two modifiers. So we have a modifier here, a modifier here. Now these modifiers are going to be our check part of the check pattern. So we have, check, effect, and then interact. So this C is our check with the modifiers, and down here you can see in the contract that's then inheriting from the owner via is. Now this inheritance is then calling the modifiers, so we're doing the checking piece. So in this function here, we're ensuring that the costs is meeting the requirements here for this modifier, and then down here we're doing the same thing for only owner. And that's just one example of how modifiers are utilized commonly for common checks. So instead of doing a specific requirement statement for all the different functions, if those require statements are all similar and identical to what's being checked, then you should just create a modifier, inherit it, and then apply it where it needs to be applied instead of copying and pasting or re-implementing things consistently. And an example of this is another one from the same YouTube channel that you should basically watch all the videos from this person. That's more of this video is watch all their stuff instead of mine, and you will learn a lot. And specifically in this multi-sig wallet presentation, he speaks to that very example. And you can see here inside of this video at this point in time at 10:50, he's referring to a function he's creating, and this function is actually going to have a series of modifiers inside of it. And all those modifiers are going to be established above so you can be applied later on. And that's a good example in context. Another one, and I think what I wanted to show here, I think this is just the point that I wanted to show is in the context of what they're mentioning, you can see they're calling out the fact that there's a series of require statements that could all then be modifiers because they're leveraged elsewhere. And this is consensus. All right, making progress. We are doing stuff. All right, Anti-Fragile, great book. You should read it. Nassim Taleb, it's a great book. All right, so here we're talking about building anti-fragile systems. So what does it mean to be anti-fragile? What is the definition of anti-fragile? Well, what doesn't kill you makes you stronger. Go read the book. All right, here to do this, there's a few general pieces of advice that correlate to what anti-fragile systems in consensus's definition is. And that is basically ensuring that the functions that you're creating have a single responsibility. So you're not building functions that are too complex. And these are common just development patterns in Web 2. This is not a Web 3 specific thing. It's just general good coding practices. And that's making sure that your functions are as small and as simple as possible so there's not hidden complexity or too much dependence within this function. So that's one piece, and that's another thing that you'll commonly see within microservices. And this piece here is referring to reliance. So this one here I had a quorum with because I've been researching more about security problems of today's issues, like modern security issues within Web3. But the point here is basically stating that you should reduce your reliance on external systems. So make sure that you don't have a lot of dependencies on others, but this is a common issue in Web 2 and will be a common issue in Web 3. And you can see I've stated here a note that it's being more of a concern today, and it's less likely that this here will be a common thing that people can actually achieve. Reason being is that within Web 3, specifically in the DeFi space and other spaces are adopting this, is the importance of composability, where you can have a series of contracts. So I have a contract 1, 2, and 3. All of these rely upon each other, but also in addition to that, you could have 6 and 7 here, and then 8. And you can see that this contract is built on 8, this contract is built on 8, they're relying on each other, and then these contracts here are built on these contracts, and everybody's building on top of each other like Legos. And that's kind of the premise, one of the premises of DeFi. And if you actually look at this lecture here, that I've not completed, but I've watched half, and I'll finish the other half probably today or tomorrow. It's Samsung, which kind of everybody talks about as being like the guru and the holy grail of security. And he speaks to a lot of this information here in this lecture specifically, and I'll link it below. And he talks through some of the modern security issues that we have today, and how specifically what we mentioned here, that being non-reliant on other systems is going to be a difficult task, and it's going to be more and more of a common practice just to build on top of other stuff. So that kind of naturally brings more complexity, and that complexity brings more vulnerabilities and all that stuff. Okie dokie. Next is inheritance. And the point here was that within this audit of specifically Opel Zeppelin was doing an audit, and they noticed that a lot of the code was actually being re-implemented or copied and pasted from other contracts. And a downfall of actually copying and pasting the code from another contract is that when that code is improved over time by either fixing bugs, adding features, adding more security, things like that, you're going to miss out on that because you've literally just copied and pasted a static point in time of that code, and you're not living with it as it evolves. And I have an example here of a simple import statement. So you're importing from this contract, this ownable.sol, and then here you're then going to inherit that contract, as an inheritance, and then you're going to leverage the function from that. So instead of copying and pasting this into a separate file or in the same contract, you're actually just going to pull it in from the origins. So when it is updated and it is improved over time, you can benefit from that as well. So that's one important piece here in the audit. And here's just a simplistic understanding of the contracts and how they're inherited. You can see that we have contract B, C, B, and A. So you can see contract B inherits from contract C. And then you can see that basically states that contract C is B, so you're inheriting there. Contract B is A, vice versa. Okay, so this is the base contract, secondary, third. And that is kind of the intuitive understanding of how it's connected. And with that, we should check this off because it feels good. It feels good to the endorphins that I'm getting from doing this. All right, this is the last one. This video is kind of short, so kind of like that. All right, and here we're talking about uints. And these are integers, and these integers, when establishing an integer or a variable, commonly there's, actually not commonly, there is a 256-bit slot that this data is input inside of. And one of the bits of code that were mentioned here is that within the code in the audit, they noticed that some certain scenarios within the code, when you're establishing a state variable and things like that, people were setting it up as a smaller uint. So they were setting it up as like a uint 8 or a uint 32 or things like that. And when you do that, you're actually wasting gas. It's not as gas efficient as establishing it as a 256. Reason being is that the EVM only takes 256-bit slots, so that means that they're going to have to perform a specific execution to zero out the unused bits. So if you only use a smaller subset of that, then you're going to have them zero out the rest. And I actually have a snippet from a video that I've linked here. So this, not this video, I'll explain that, but this is a good video to watch in general if you're interested in smart contract security, but specifically at this point in time, I think it's an hour and 50 minutes in. This specific YouTuber talks through how you could waste gas by doing the same thing I've just mentioned here, and he kind of explains it in his own way inside of the context of doing an audit. So I thought that was useful. And this code snippet here is from this video from the same YouTube that I've mentioned a million times. And in here specifically, he explains how the slots work in the storage for the EVM and how the zero out concept works. And you can see the finished bit here, where here we have a 32 byte, so that's 256 bits, and that's actually being stored here. And that you're basically using the entire space, right? So you start with 0x, and the rest of this is full, so you're using everything. Same applies for this one, because you're using a 32 byte, which is a bit, 256 bit, and you're using everything. Now here you can see the uint num isn't using everything, it's only using the 7b, and then here the address is only using this yellow section, and then we have the boolean, which is this orange section. Now with that being said, you can see that we're zeroing out everything here. And that's the point that's being made above, is that before this is actually zeroed out, there's a certain amount of gas that's utilized to complete that function and that execution. And with all that being said, there's also one last bit of here that I've came across, which is an oldie but a goodie. We have Haseeb here that did a lecture and a presentation specifically on scalability, but he talks a lot through memory, storage, and caching, and explains that in Web 2, but it's very relevant, it's all relevant to Web 3. And I thought that was a good one to point out, and I'll link below as well. And with that being said, that is everything. So I know that this isn't, as in depth as you would get here, but really the big point here is to, when reading these, is to not get too overwhelmed. Skim, don't get too deep in the details, and if you want, you can dive into certain audits, but really what I've taken away from this is that I really want to dig through one report at a time. Also watch a lot of lectures in cadence with reading the audits themselves, just to understand the patterns and the common security flaws that people come across that are more experienced than I am. But in all, I hope this is useful for you, and I'll see you in the next video, which will not be the Security Bootcamp, which I'm excited about.